Hi, let me tell you about another great Manning book, Grokking Software Architecture, a friendly guide for programmers and other curious people, written by Matt Ehrman.
Software architecture is not a private club, senior-only title, or stack of diagrams. It begins much earlier. It begins in ordinary decisions: where logic goes, how data is stored, how a feature ships, and what consequences the team accepts when time is short. Every developer is already making architectural choices. The problem is not a lack of influence. The problem is making those choices without the blueprint, vocabulary, or confidence to understand what they will do to the system later. To succeed in modern software development, you need to understand the 3 A's of architecture. Architectural awareness, the foundation, means recognizing when code is shaping the larger system and knowing enough to ask the right questions. Architectural alignment, the bridge, uses that awareness in daily work, so local coding choices support the system's broader goals. Architectural accountability, the destination, is the responsibility for final system-wide decisions, where experience and seniority legitimately matter. The point is not to pretend that a junior developer owns every database choice or service boundary. What matters is recognizing that architecture is not something far away. Awareness can start on day one. Alignment can be practiced in every task. Accountability comes later, earned through better judgment. Architecture becomes real when checkout must ship by Friday. The fast path puts payment logic into the controller and accepts future maintenance pain. The cleaner path creates a payment service and invoice generator, protects the design, and misses the release. There is no magic third option. Architecture is choice and consequences, deliberate trade-offs under pressure. Technical debt is not always evil. With a clear plan, it can be a business decision. The danger is unmanaged debt, where nobody admits what was sacrificed. The opposite danger is over-engineering, where fear of debt turns a simple feature into unnecessary complexity. The goal is clarity, not complexity. Architecture is the shape of a system and the reasons for that shape. Decisions that affect how it is built, tested, deployed, and changed. Think of a food truck. Service window as API. Cook as business logic. Grill and fridge as database and cache. Structure, stress behavior, and evolution all matter. Adding a new taco should be easy. Turning the taco truck into a sushi truck is a much larger architectural change. If a decision will make the system significantly easier or harder to build, ship, or change later, it is architectural. Architecture is also about people. Business needs arrive as vague requests. Make it faster. Add a favorite button? Can we ship by Friday? A clarity engineer listens before coding and asks why until the real constraint appears. A favorite button may really mean a marketing deadline, user feedback, or return visits. Without that inquiry, a developer can build a cleaner solution and still fail to meet the need. With inquiry, the trade-off becomes visible. Maybe speed to ship matters more than long-term scalability for this first version. That is not laziness, that is alignment. Architecture is a process that starts with the spark, the what, the initial request. What should the user do? Where will it appear? And is this a new or changed flow? Then comes inquiry, the why. Ask why. The 5 whys drill past the surface-level requests until the root business driver is visible. Next is the sketch, the how. This is not formal UML, it is a simple map of responsibilities. Without that inquiry, a developer can build a cleaner solution and still fail to meet the need. This protects separation of concerns. Display code, business logic, and storage stay apart. Then come options, the trade-off. Maybe favorites are stored directly on the user profile for speed. Maybe they get a dedicated storage area for scalability and maintainability. Each choice has costs. Finally comes the decision, the receipt. Write down what and why it was chosen, and what consequences are accepted. That written receipt makes the decision defensible. If priorities change, the team knows exactly what to revisit. The focus is practical enterprise software architecture from a developer's perspective, structuring code and data so systems stay maintainable. The journey includes patterns, APIs, event-driven architecture, databases, microservices, deployment, quality, observability, and communication. The key skill is not memorizing one perfect architecture, it is learning to think, build clean systems, and navigate legacy code without rewriting everything from scratch. AI tools help only with architectural thinking. Friendster shows what happens when the wrong priority wins. Launched in 2002, it briefly became the beacon of the new social network era. The platform chased perfect consistency. Every new connection had to appear globally and immediately, forcing expensive database work on every page load. As the network grew, performance collapsed. Competitors chose availability and performance even if a connection took seconds to appear everywhere. Brilliant engineering does not guarantee good architecture. Optimizing for the wrong quality can sink the product. Your mission is simple. Take one technical decision, name two realistic options, list one benefit and one cost for each, and write the final choice with a one-sentence rationale. That is the compass in action. Build awareness, practice alignment, ask better questions, make trade-offs visible, keep receipts for decisions. In Chapter 2, the Architect's Decision Toolkit, the next step is learning how to weigh the competing abilities that pull every system in different directions.
Get this book at manning.com